Leetcode question 105: construct binary tree from preorder and inorder traversal. So we are given two arrays, and these are preorder and inorder traversal of a binary tree. So we have to construct a binary tree from it. Okay, got it. So um, so one thing to notice is I don't know. Okay, this is not BST, but we have preorder and inorder traversal. One thing is that in inorder traversal we go left, then we process the node, then we go right. For this node we go left, then we process the node, then we go right. That's the inorder traversal. And preorder means we process the node first, then we go left, then we process this node, then we go right, then we process this node, then we go left, process this node, and this. So that's what pre-order and post-order is. Okay, so uh, I'm going to go with my default checklist. Right, so we have two input arrays, int arrays, right? Pre-order and in order. Okay, let's that's fine. What's going to be output is going to be a root node of binary tree. Cool. And let's talk about size. Is it possible that these arrays are empty, or they cannot exist, something like that? Let's see. Yeah, so at least there will be one element, and for this example we have at most 3000. So in real interview we have to ask this question. What about the values? Can the values be, I asked this question in each interview, and the values be negative, positive, 0, and are there duplicates allowed? I think in this case it's all valid. So negatives allowed, positives obviously allowed every time. It can be 0, and I think there can be duplicate nodes, but I think um, in this case there might not be allowed a duplicate. Yeah, see, consist of unique values, duplicates are not allowed. Okay, so once you clarify that question, I have a pretty straightforward checklist, which is H or test cases, algo design, code, time, space. Yeah, so I will come back to edge case test cases. Basically it can be we have taken care of this, right? And there cannot be an empty list, and and hmm, and and is there anything else that can be a test or edge case? Basically in trees I think there are few cases to be tested, like a skewed tree. Empty is not possible in this case. Zigzag, what I mean by that is it has a right then it has left, then again it has only right, then it has only left. It can work, it can catch any bugs. So let's go ahead. Algorithm design. So let's say we have given a tree and we have the in order of it. So how it's going to be look, or let's do first preorder. So when we start at root, preorder means process this node and then go left and right. So it's gonna be like something like node, and then this part will be the preorder, sorry, left, and this is going to be right tree. And for in order, it's gonna look something like, first we will process the left tree full, then we'll process the node, and then it's going to be right tree. So now when we have in order and pre-order, that means this node is going to be root of the tree, right? And then we have to figure out what is left and right. So we can figure it out by in order. So once we find the node, right, uh, then we find that node in order, and whatever left of it is, that's kind of a um uh, that is going to be the left subtree of this node, and after that is going to be right subtree of this node. So what I mean by that is, let's say for this example we have 3 as a starting node, so we understand that, and we check what is the index of 3 in order. So we found this. Now it means that after this index, all these will be in the right side, and before this, whatever the index are there in here will be in the uh, left side. So we have to work with the indexes, and once we do it for like first element, right, then we can recursively construct the tree. So once we have done this, we call same function on this side of the tree and this side of the tree. Does it make sense? I think that's the way to go. So let me see if I can come up with an algorithm for that. Hmm. Um, yeah, it's gonna take some time to come up with this algorithm. Like, algorithm is understanding, but the code is gonna be I'm not, I'm trying to understand how can I code it. Both of these are arrays, right? So um Can I get indexes of this in order? I think I can map, let's say, map in order is equal to this, and then for node comma value, sorry, index comma value in enumerate in order. Map of in order of value is equal to index. So now this the one of the case comes in handy, because each element is unique. We don't have conflicts with the indexes. Yeah, so what this is going to do is we know the pre-order this first, right? So once we know this, we get this index directly from this map in order, and then we iterate on this side and this side. Okay, fine. Cool. So I'm going to have a internal function, let's say dfs. It's going to take left pre-order index, right pre-order index, left in order index, right in order index, yeah, and we at least have one element, right? So this is gonna work. So yeah, in ideal interview, naming these like something better is good idea. For now I'm just gonna keep it. Now what? Yeah, so so first thing, what I want to do is create a node which is going to be a tree node, and it takes the value, right? So tree node with the value of pre-order and the value which is at the left index. Create this node. So we created node with this value, and then we want to create left and right subtree. So what I'm going to do is node dot left is going to be dfs with some values. Node dot right is going to be dfs with some values, and we are going to return node. So yeah, but there is there a possibility that we can go out of index? Yes. So Yeah, so in case if left pre is greater than right pre, return null. So that's kind of a base case for this DFS solution. Okay. Yeah, now calling the left, how can I be oh man, this is difficult. Okay, so I get the index of this value in order. Okay. Which is this value. I get index from this. So once I get this index, it's going to be 1. So okay, so what does that mean? And let's say I do this. So so based on this index, how can I make pre-order indexes for left subtree? Okay, so so for this case, left index is going to be it's going to be same index, the left index. Yeah, and right index is going to be whatever this index is minus 1, right? So idx minus 1. That's what we figured it out. Now in right case, when we want to go to right side, it's going to be index plus 1. So whatever this index is, it's going to be idx plus 1, and right index is going to be remaining the same. Okay, so now we have indexes of this part. How do we figure it out, this part? How are we going to figure it out? It's going to be some calculation, right? uh, Okay, so it's going to be, I understand here. So whatever the left index was, now it's going to be starting from next index, that's for sure. So we cannot use same index. So we start from the next index and we end at what? That's the question. So how many values we need from so it's going to be the value uh, in index, so 1 minus 0, right? That is I'm writing really complicated code here, is going to be index minus L in, so index is 1 minus left index is 0, that is 1. I think this is correct but not sure. And what about the right index? So it's going to be this plus 1 plus 1 and so we are going to start here and it's gonna end at rightmost value, which was r pre. Yeah, and then what we do is we call this function with starting all indexes as 0 0 0, no sorry 0 not 0, length of preorder minus 1 0, length of Inorder minus 1, but both are same so doesn't matter. And it's going to return us the root node, so we return the root node from here as well. Let's find out. It's going into infinite loop, I think. Oh, it work for this case, but it will fail for like many other cases, I think. It's working, but I am still not convinced that it's right. There are some one-off errors in this, which should be calculated on paper and something. But if this code doesn't work, I'm going to check my previous submission and just paste it here. But I hope it works. It's been like 6 months I have solved this before. I did not expect this to work, but somehow it worked. So that's a great start, and it's pretty efficient. See, pretty efficient memory wise. Let's see what I wrote like previously. Oh, it was kind of a recursive function. This case was not required because of the constraints. Yeah. So basically this thing, right, in order dot index of preorder of 0, what this is going to do is it's going to scan the array every time. And then for root dot left, root dot right, I'm passing a full copy of array from the existing array. In my current solution, it's like space efficient and also time efficient. So yeah, so it's a good point to mention the time and space complexity right now. So code is done, algo was done. Time complexity is like what? We are going through each node once, and this is done once. So we get the index at in order as well as O of 1. So uh, it's going to be O of n, as we are going only once through each node. And about space complexity, am I using any extra space? Okay, so I'm using a map of n values, so that's O of n, and I'm creating n nodes, so that's again O of n. So yeah, but uh, my code is only using this map, which is extra space. Other than that, it's required to have these nodes, right? It's a part of question. So yeah, that's pretty much it. I'm glad that I was able to solve this question. Thank you for watching.